Andrew Forbes, welcome to Conversations in Science.
Thank you.
So this series that you started in the Faculty of Science is more about finding out more about the scientist behind science. You have an unparalleled record here at Wits in terms of the work that you do in photonics. I guess it's variously described as optics, structured light, and so on. Where did it all begin?
I guess you can trace it all the way back to one's studies. That's where everything begins, right? And I was very lucky to have found somebody who was working in optics, who was doing fantastic stuff, Professor Max Michaelis. At the time, actually, I was going to become an astronomer, but I was intrigued by the work that he was doing. I was intrigued by the creativity that he was showing, and I decided to switch directions.
So that was at the University of Natal, right?
I was at the University of Natal in Durban.
And you saw the light then?
Saw the light, that's right.
That's fantastic. So you did your PhD with Max then?
I did my PhD with Max as the supervisor, but in fact I did it at the Atomic Energy Corporation up in Pelindaba.
Yeah.
At the time, South Africa had a uranium enrichment program.
Yeah.
Not for weapons, but for fuel. And it was a laser-based program. And so my PhD was in a big research institute. So I moved from a small university department for my master's to a large research institute for the PhD.
So I would say that that many of the scientists working in that environment really looked at light as a probe into other systems. I mean, that's the generic situation. You use light as a means to study other systems, but you chose to study light itself. And tell us about that. What fascinates you about manipulating light, photons ultimately? Because many folk also work in the classical regime. You've chosen to kind of really pivot over into the quantum world of light and share with us some of your thinking around that.
Well, I guess there are two parts to it. The one part is from Max Michaelis, I learned the importance of creativity. So that opened my mind to asking difficult questions and not being afraid to try to answer them. And more importantly, trying to ask the right questions. So in my group today, we put, I would say, more effort into asking the questions than we do answering it. We really probe the question very, very deeply. That's the first point. Second point is that I realized that actually, at the time I was doing my PhD, prior to that, if you wanted to control light, it would more or less be with refraction or reflection, so lenses and mirrors, perhaps the odd grating and prism, but again, very, very little control. And what happened at that point in the early 90s was that all the microelectronics industry, which had pioneered this lithography processes, that could be used now to produce micro-optics. And micro-optics meant that you could start to manipulate the phase of light, which was not possible before. So you had computing power, which meant you could compute the solutions, and you now had the fabrication power to actually make the optics. So this world of diffractive optics exploded. And in fact, how I found it was that I wanted to go to a conference in Scandinavia. I had never been to Scandinavia. I had never been to an international conference, so I did a search, and I found this conference in Finland. I thought, just the thing. What is the topic? It was micro-optics and diffractive optics. And I had no idea what that was. So I thought, let me read a bit before I pitch to go to this conference and find out what the field is about. Discovered it's about shaping and controlling light. Promptly forgot about the conference and delved deeply into this field. And that field I have now, I guess, pioneered and changed its direction to be not just the phase of light, but all of light's degrees of freedom. And it really was to just get to this conference in Scandinavia. And I did get there, but I got there 15 years later. So 15 years later, I gave a keynote address at this conference. They invited me to talk about the new field of shaping light and where it's going. And I told them, as a student, I wanted to come here 15 years ago.
So you never made that meeting 15 years ago.
But here I am today to tell you the new direction that this field is taking.
Well, that's fascinating. That's really an incredible story. So It's wonderful that you acknowledge those that have inspired you in your work. But what I have experienced as Dean of Science here at Wits is the manner in which you've approached your students. For one thing, many of your students have gone on to do incredibly successful things. They've been employed in industry. Some of them have continued with an innovative career, but importantly, a number of them have stayed on within the academic setting. And that's a hallmark of a great supervisor. 2 years ago, you got the Faculty Supervisor Award. So I really appreciate the fact that you continue to inspire our students to the extent that you do. Well, what is your approach? How do you approach student interaction and supervision as different from many others, because you really stand out quite brilliantly in this way?
We do a number of things differently. I mean, first, we almost never look at the academic record of a student, which is a little bit unusual. I sit with the person, we discuss their strengths, where do they want to go in life, what are their ambitions, what are they not so good at that they would like to improve on. And then what we try to do is we try to tailor a project that will match their skills. So we want to play on people's strengths while improving their weaknesses. We don't want to show people what they can't do. We want to show them what they can do. We explain to them at the beginning, look, I believe that no pressure is very bad. Too much pressure, that's unhealthy pressure, is also not good. But a little bit of tension in the system where you're kind of pushed to excel, but it's hard to get there, but you can get there. That's very good. And so we try to find this point where they're in tension, but they're not in stress.
Well, that's amazing, and you have fantastic facilities as well. So this is all the people side of things, but it's also the technology in the lab that you've set up that must be very inspiring for anybody to walk into.
Yes, we when we select students, it's a very long process. We begin usually with holiday work. So every year we select students from the class who are enthusiastic about the subject. We take them into the lab and we expose them to all the projects we're doing. They do a summer vacation project. They usually come back for a winter project. And so, yes, over the years, we've built a world-class facility. And what we tell people is that what makes our lab different to, I would say, the typical physics lab is that we don't have instruments. We don't have a machine where you put your sample in and you press some buttons and it does something. We have empty optical tables. We have a lot of equipment, but it's all modular. So what that means is when we start an experiment, we build it from scratch. We assemble the experiment, we try out whatever the idea was, and then we break it all apart. And we go on to the next idea. And this is very important because it doesn't lock us into a particular way of thinking. Every step forward is a blank piece of paper. What shall we do next? We are not locked to a 10 million rand machine. We're only restricted by our own imagination.
That's so poetic and so inspirational, very philosophical how you put it. And I wish that some of these ideas will also translate more broadly into the Faculty of Science. So I'll come on back to you to get some of those ideas. I like the way in which you approach things. You're a senior researcher, hugely accomplished, but still you continue with mainstream basic things that I like to see in any academic, which is also being involved in teaching. The number of senior researchers here that balk at the idea of being involved in teaching. So I just want to say that you really epitomize for me what a complete academic is. And of course, you've been recognized in multiple ways. I mentioned the Supervisor Award. Of course, you have the prestigious SCIP Gold Medal from a few years ago, and very recently now, and congratulations on your Oppenheimer Memorial Trust Award. This is magnificent, a real testimony of all of your accomplishments. What next then, Andrew? What is the next levels of success that you aspire for?
I think the awards are wonderful. It's wonderful to be acknowledged for what you've done. But it's really not what drives us. I guess we're driven by the science. Journalists often ask me, when we've made the news for some wonderful discovery, they'll say, so what's next? And what's your favorite accomplishment? And I always say, my best discovery is the next one. And I really do believe that. I tell the students, we're competing internationally. We want to, well, when I get new PhD students, the first thing I say to them is, what are you going to be famous for? That's what you're here for. You're here in 3 years. You should leave being famous for having done something. When they think your name, they say, oh, Pedro. Pedro is the guy who did the first quantum topology. That's what we want from the students. And it's this drive that results in outputs. So my outputs are very small compared to my students who have won hundreds of awards for their fantastic science.
Thank you for creating this very nurturing environment. I really appreciate this. And scientists, of course, never stop thinking, right? Way into the future for many years to come. I hope that you will continue to find a happy and successful home right here at Wits University. I think the university is a great one. I've worked at many different universities, but this is really very exciting and very inspiring place to be.
Wits is an absolutely fantastic place to be. It has wonderful leadership. It has fantastic students. When I moved to Wits from the CSIR, at the CSIR every year, as I said, we would stand in front of this panel and say what we'd done in the year. And it was very unbalanced because most people were not pushing themselves to excel. But I knew when I moved to the School of Physics that I would be amongst very competitive, very smart, very driven people. And that's proved to be true. And it's wonderful because I want to be in an environment where we can celebrate the success of everybody. If somebody digs up a wonderful new skill and it's on the cover of Science, it's part of my success. I can go around and say, oh, look how wonderful this is that my university is doing. And I want to be amongst people like that. And I feel I am amongst people like that. So wonderful leadership, wonderful colleagues. And I think the best students that you could find in South Africa. So why would you want to be anywhere else?
Well, that's so nice to hear. As Dean of Science, I'm very proud to serve the Faculty of Science. And it's just a world-class environment where folk right across the faculty are doing very exciting things. But I do worry about the future of science. Around the world, we're beginning to see changes in the science landscape. I've just come out of a meeting in Brazil that was the BRICS Academies of Science meeting, and that was largely focused on the changing funding landscape across the US, and of course, which has impacted right across the world, of course, including right here at Wits. One said that the Faculty of Sciences is negatively impacted to the extent that the Faculty of Health Sciences is. There are many research programs there based on HIV, AIDS, TB, and so on that have been completely decimated in one fell swoop. So we need to pay attention to this. We really do. I worry an awful lot of the ways in which politics has ended science, especially in the climate science environment, where the distinction, demarcation between the science and the politics has been blurred by folk who have an agenda for blurring those lines. But what are your thoughts about the future? What do you feel that we as scientists, senior scientists, including yourself, whose voice is heard across the nation and beyond, what do you feel that we should be doing a little bit differently or perhaps doing a little bit better to ensure that the next generation of scientists can enjoy the sort of careers that we've had ourselves?
Well, let me first go back to the turbulent world in which we live in at the moment. In the photonics sector, we have very large international societies that drive a lot of our big conferences. They manage a lot of our journals. It would be true to say that without them, the community would be a shadow of what it is. And they are mostly US-based. They now call themselves international societies, which is quite correct because most of their membership is outside the US. But there is a risk that there'll be a bit of a pullback. There's already some mutterings that, mentioning diversity in conference committees or in the speaker lineup is maybe not as important as it used to be. And so I think there is a pullback and we have to guard against that. I think people who have a voice need to use it. I do have a voice in that community, and I definitely do use it.
Science is so important for bringing people together across so many divides, historical, geographical, cultural, and so on. And I've certainly dedicated much of my life to ensuring that scientists bring people together rather than be influenced by a world that of politics that tears us apart. And so your international collaborations do really help us greatly here on the southern tip of Africa to help draw those linkages together. So I just want to thank you on behalf of Wits University for flying the flag for Wits so incredibly high, and wish you all the very best for your future.
Nithya, thank you very, very much, and thank you for all your support.
My pleasure.